This is Nana Ravi Shankar, research scholar, BS Abdul Rahman University, Chennai, and my research area is ontology-based clustering algorithm for information retrieval system. And the agenda of the presentation is introduction and objective, then literature review, then the proposal of the system, then operation of the system and the implementation result, conclusion and references. First, the introduction. So, clustering is the main area in the field of web mining because in today's world, information overloading is the challenging research area. So, the user has to retrieve relevant data from the web is a challenging issue. So, how efficiently and effectively the clustering engines retrieve the results from the web is a research area. And in this research, we have used ontology-based clustering and study the performance of the proposed system. The objective of the research is to integrate domain ontology as a background knowledge and study the performance of the proposed clustering engine. So then the literature review. So in this is the base paper of our system. The title is Enhancing Traditional Text Documents Clustering Based on Ontology. So in this paper they have presents the concept for creating weighting factor for the text clustering systems. But the main drawback is it doesn't work except for semantic web. So it doesn't work for ordinary webs. So it will be effective only for the semantic web. And the next one is the mobile information retrieval. So this is another one famous paper written by Claudio Carpinetto. Right? They have developed a clustering engine for both desktop as well as mobile. They have taken subtopic reach time as the metric. But the difficulty is when users retrieve different documents, it doesn't work well. Next one is similarity measures for text document clustering. So in this paper they have compared and analyzed the effect of similarity metrics with and without the presence of ontology. So in this they didn't justify how to choose a metric for a clustering engine. And then the experimental results more or less same for all the metrics. And next paper is utilizing term proximity based features to improve text document clustering. So in this paper they try to enhance text clustering by introducing a feature called term swap feature. So the gap is here that they didn't get the significant result because of the term swap feature is selected in the document itself. And the proposed system, so this is the proposed system architecture. So in this, the document to be clustered is given to the first phase. So there are mainly 4 phases in our architecture. The first phase is pre-processing. So in pre-processing, the stop words are removed. Stop words like A, D, on, here, stop words are removed in the pre-processing phase, and then we can apply ontology. So ontology here apply in terms of decision tree. And next phase is k-means algorithm. Standard k-means algorithm is applied to the text documents. And last one is the cluster results are validated. So here decision tree is taken as a normalization or ontology. So ontology and normalization are often exchanged. So here a simple dataset like labor dataset which has 57 instance and 17 attributes. So using Vega tool, this tree was generated. So this is a simple normalization tree which is based on wages, bad wages. If it is less than 2.5, it goes to one group. If it is greater than 2.5, it goes to another group. So external validation. So to validate our clustering results, we form 2 hypotheses. One is override in terms of time taken by the proposed method, right? So the time taken by the proposed method to retrieve the result, and then response time to retrieve the relevant documents from the web. So these 2 hypotheses are formed to validate our clustering results, and then the implementation results. So all the documents are implemented in Java and the k-means algorithm. So implementation results, so this is the summary of datasets used. So in order to ensure diversity of the clustering results, we have used different types of arguments which is different in terms of attributes, instance, size, etc. And the main objective of the k-means algorithm is to reduce the residual sum of square distance error. So the distance between the centroid and the other objects should be reduced. So then implementation results. So to ensure diversity, we compare our result with the traditional baseline systems. So from the table, we can see that the clustering based, ontology based clustering can improve the performance of the system, and the graphical representation of the table is presented in the diagram. While conclude, the primary contribution of the result is to ensure that the similarity measures in the experiments, whether with or without the presence of ontology, is increasing the clustering performance or not. And then the experimental results show that ontology based clustering produce marked changes in the result, and also it is better to normalize the data before applying the clustering algorithm. And finally, can be applied for complex and real-time data sets. So these are the references for our paper. Thank you.